Hey guys, in this video we're going to look at some quadratic transformations, and this is going to involve stretches, compressions, basically making the graph wider or narrower, or reflecting it across the x-axis. So let's get to it. We have our parent function x squared and we want 2x squared. So what happens is the 2x squared is going to take all of your y values and multiply them by 2. So previously, whatever they were, they're now doubled, which means your graph is going to now get narrower. So let's see. It's still going to be at the origin because it didn't move left or right and it didn't move up or down. Okay, I'm not dealing with those yet. I'll deal with those in the next section. But it is going to be multiplied by 2 each time. So if you remember, it went over 1, up 1. So now it's doubled everything. So over 1 up 1 times 2 is 2. And we'll be on either side. It used to be over 2 up 4, but now it's doubled, so over 2 up 8. Well, I can't fit that onto this graph because the graph's not big enough. So I can only get these 3 points on there. So I'm going to go ahead and smooth this out as best I can. And it definitely looks like the graph got narrower. And so for me, it's kind of hard to graph these, but that looks pretty good right there. And then you've got your axis of symmetry right here at x equals 0. All right, our next one is 1/2 x squared. So this time, all of your y values are going to be cut in half. So still going to be at the origin, the vertex, because it didn't move left or right or up or down. So it used to be over 1 up 1, but now we're taking half of all the y values. So instead of being over 1 up 1, it's now over 1 up half of 1, or half. Okay, it used to be over 2 up 4, but now it's half of that. So over 2 up 2. It used to be over 3 up 9, but now we're taking half of that, so over 3 up 4.5. Because 4.5 is half of 9. And then it used to be over 4 up 16. Half of that would be 8, and we're off of the graph. So we're going to go ahead and smoothly connect our dots. I think I'll do it this way this time. And that looks pretty good. Again, we have our axis of symmetry at x equals 0, like most of these are going to be anyway. All right, this time we have a negative 2x squared in front. So not only are our values for y going to be doubled, but they're also going to be negative, which is going to flip the graph down across the x-axis. So vertex is still at the origin. So it used to be over 1 up 1, but now we're going to go down because of the negative, and we're going to double it. So over 1, and instead of up every time, I'm going to say down. So instead of over 1 down 1, it's now over 1 down 2. It used to be over 2 down 4 because it's negative, right? But now you're doubling it, so it'd be over 2 down 8, and we're off the graph then. So it looks like this is pretty much all we can do. Okay, this one, negative 1/2 x squared. We have a negative in front, so we're going to flip it across the x-axis, reflect it, and we're going to take half of all the y values. So our vertex is still at the origin. It used to be over 1, and I got to say down now because of the negative, over 1 down 1, but we're taking half of that, so over 1 down 1/2. Over 2 down 4 it used to be, but now we're taking half, so over 2 down 2. And we see our graph is going to get wider. Over 3 it used to be down 9, but now it's half of that, so 4.5, 4.5. Right there, and that's all we can fit on there. And so now we're going to connect our points smoothly and make our parabola. It looks pretty good. All right, this one says 3x squared, so now all of our y values have been tripled. So now we're going to take our vertex, put it at the origin again. And it used to be over 1 up 1. Now we're tripling it, so over 1 up 3. Okay, if we had a bigger graph, it'd be over 2 up, used to be over 2 up 4, but when you triple that, it'd be 12, and it's going to make your graph really narrow, but we can't fit that on here. So we're just going to go ahead and connect our points as smoothly as we can, and that's a pretty decent looking graph for what we have there, narrower. Okay, this one, negative 3/4 x squared. Now, all of our y values have been flipped and they're 3/4 of what they used to be. So I'm going to use a calculator here to kind of help us out to determine where some of these things are going to be going. So we're going to start at the origin. It used to be over 1, and I got to say down, right? Over 1, down 1, but now we're taking 3/4 of that. So it's going to be over 1, down 3/4, which is going to be about right there. All right, it used to be over 2, down 4, but now we have to take 3/4 of that. So 3/4 of 4 is going to be 3. So now we're going to go over 2, and that will be down 3. So over 2, down 3, over 2, down 3. All right. It used to be over 3, down 9, but now we're going to take 3/4 of that. So 3/4 of 9, and that's going to be 27 over 4. And if we put that in our calculator, 27 divided by 4, we get about 6.75. So it's going to be over 3, down 6.75. So it's going to be a little bit off the graph, but it's okay. We can probably fit that in. 6.75, there's 6. It's just going to be at the bottom, like right there. Okay, so now I'm going to go ahead, connect my dots, and we see that it did get a little bit wider. Ooh, went off there a little bit. That's okay, that happens. And there's our graph. It got reflected across the x-axis, and it widened because of the 3/4. So when you have a number in front of the x squared, a coefficient, we say, that's between 0 and 1, it's going to make it wider. And if it's bigger than 1, then it's going to be narrower. All right, here we have 0.6x squared. So like what I just said, this one has 0.6, which means it's going to be wider because that's between 0 and 1. So we're going to be at the origin, and it used to be over 1 up 1. It is going up, but now it's 0.6 of that. So over 1 up 0.6, which is going to be a little bit more than halfway. So we'll go right there. It used to be over 2 up 4, but now we have to take 0.6 of that. So 0.6 times 4. So 0.6 times 4 is 2.4. So we got to go over 2 up 2.4, which is about right there. It used to be over 3 up 9, but now we have to take 0.6 of that. So 0.6 times 9 is 5.4. So over 3 up 5.4 is going to be about right there and right there. So that's all I can fit on there. So we're going to smoothly connect our points. And that's a pretty good looking graph. Okay, this one is going to be negative 1.5, so it's going to be narrow and it's going to be flipped across the x-axis. So here we go with this one. Start at the origin. It used to be over 1, down 1, but now everything is being multiplied by 1.5, so it's going to be over 1, down 1.5. The first one's the easiest. All right, now it used to be over 2, down 4, but now we have to take 1.5 of that. So 1.5 times 4 is 6. So we're going to go over 2, down 6. And we did get a little narrower, didn't we? So that's all I can fit on there. And that's a good looking graph right there. Okay, this one, negative 1.5x squared. So this time we're going to be reflected across the x-axis, and we're going to be 1/5 is 0.2, so that's going to be wider, probably quite a bit. So we're going to stick with the origin for our vertex. It used to be over 1, down because it's negative, but 1.5, or I'm sorry, 1/5 is 0.2. So that's going to be over 1, down just a little bit. 0.2 is about right there. All right, so here we go. It used to be over 2 down 4, but now we have to take 0.2 of that. I like the decimal a little bit better. You could do the fraction if you want. So if we do 0.2 times 4, we get 0.8. Okay, so we're going to go over 2, down 0.8, which is about right there. So that one looks pretty good. And so now let's do 3. So it used to be over 3 down 9, but now we're going to do 0.2 times 9. So 0.2 times 9 is 1.8. So over 3 down 1.8. And we see that we're getting significantly wider, which is what we're supposed to do. It used to be over 4 down 16, but now we have to take 0.2 of that. Okay, so 0.2 times 16, 3.2. So we're going to go over 4 down 3.2, which is about right there. And now it used to be over 5 down 25. Now we're going to take 0.2 of that. Ooh, my fault. So 0.2 times 25, and we get 5 exactly. So over 5 down 5. Over 5 down 5. And just for fun, we'll take a look at 6. So if it used to be over 6 down 36. So if you take 0.2 of 36, it's probably going to be off the graph. So 0.2 times 36, 7.2. Yeah, that's a little bit too much, too far off the graph. So we're just going to keep these points right here. We'll smoothly connect them. And my first one should have been up a little bit more, but that's okay. And that's a pretty good looking graph, and we do see that it got wider, and it definitely reflected across the x-axis. All right, our last one is 2.5x squared. So for this one, we're going to remain opening upward, because it's positive, and 2.5 is going to narrow it, probably significantly. So let's see, it used to be over 1 up 1, but now it's going to be over 1 up 2.5. Yeah, I bet that's probably the only one we're going to get on there. Because if you go over 2 up 4, 2.5 times 4, in case you don't know, is 10. And that's too far. So we can't get that one on there. And because we got significantly wider, we can only fit these 3 points on there, which is very typical. And there's your graph. So this has been quadratic transformations with reflections on the x-axis and the widening and narrowing, also called shrinking and compressing. So remember to like my video and subscribe to my channel if you haven't already. I'll see you guys later. Bye.